So the next speaker is Cathy Dwyer from SRUC. Talk about what we did in welfare assessment in Take Care.
Thanks very much, Claire. Good morning, everybody. I'm going to talk you through a little bit some of the work that we've done, really focusing on what are the key things from a welfare perspective and how we assess those and how that linked to some other parts of the work. So if I take you back to the very beginning when we were young and naive and COVID-19 was an unknown thing, Claire already told us about some of the challenges around having PLF on farms, but we also have knowledge gaps or challenges even thinking about the welfare of the species that we're focusing on. So sheep and goats are a diverse group of animals, both in terms of their purpose, so meat, dairy, fiber, and the sort of husbandry systems and practices that are across Europe. So it's a really heterogeneous farming system. Even within this, some animals might transition. So we have animals that maybe spend 100% of their time outside, other animals that spend 100% of their time inside. Some animals will move between those systems seasonally. Some animals might move between those systems on a daily basis. So we have this enormous diversity of production purpose and husbandry. And within this system, we've been relatively less studied in terms of their welfare compared to other farm species. So not only are we starting with a really low level of use of sensor and PLF, we're also starting with a really complex system, and again, where we have less knowledge, less understanding, perhaps a more diverse range of things that maybe are an issue for our species. So our very first task with the work of Take Care was really to determine what were the main challenges that we wanted to explore with our development of PLF approaches. And so we set out to try and define across our stakeholder groups, across our different countries, what were the main issues that were causing concern for our farmers and our stakeholders. So we reviewed the scientific literature for all the possible mentions of different welfare issues, different diseases, different behavioral problems, different environmental issues that were mentioned for sheep and goats across any of the life stages of these animals. So we ended up with about 80 to 90 specific welfare issues for each of the species, which was obviously way beyond the scope of anything that we could actually tackle in a project. So we then went through a sort of iterative process to determine which of these were those that caused most concern to our stakeholders. So we initially reduced the number of species issues with our subgroups of experts to some that was a little bit more manageable for our stakeholders to deal with. So that was reducing it by about 2/3 to about 30 issues per species, which in general our experts felt were those that caused the biggest impact or affected the most animals or had the most severe consequences. And we then, and you'll hear more about the stakeholder interactions later, we used our network of workshops and stakeholders to reduce these to a set of priorities. So things that were a particular concern to the stakeholders in our different countries. So this is just an example of what we found from the sheep work. And we found that the purpose for which animals were kept was not that important in terms of how people prioritized welfare. It was much more important in terms of the husbandry system. So we ended up with a different list if animals were kept mostly outdoors to those animals that were kept mostly indoors. Whereas if we looked at production purpose, there wasn't a huge difference between the different lists. And you can see that there's some similarities, but also some marked differences. You'll also notice that health are issues that rise up the list, health and parasites in particular, for those animals that are managed outside. Nutritional issues appear in both cases, so a lot of concern about the feeding of animals, their health status, and for those animals that are mostly indoors, also concern about the environment. And you'll notice, just as for Clear Farm, that behavioral issues are less frequently appearing. So we do see something about a poor maternal relationship, which might lead to increased morbidity and mortality, particularly of lambs. But the priority issues were around the domains of health, nutrition, and environment. So just to summarize the key outcomes from the work with sheep, the production purpose, so whether they were kept for meat or milk, didn't really influence the main welfare issues that were identified. It was mostly the environment in which those animals were kept that affected the prioritization. When animals were managed entirely or predominantly outdoors, the key concerns were around disease, parasites, and access to suitable nutrition. When they were managed predominantly indoors, the key concerns were around the quality of the housing, mastitis, infectious disease, and access to suitable nutrition. When we consider also by species, so if we sort of merge together our sheep list and also look at what were the issues that were raised for goats, and again, there was a lot of commonalities between these two different groups of small ruminants. So you can see that although the order sort of flips around, but nutritional issues and mastitis were the two key issues for either groups of small ruminants when we merged our sheep lists. We can also see that lameness or foot and leg health and parasitism, so both intestinal parasites and ectoparasites, again appear on both our lists. So again, we're seeing very similar concerns raised by our stakeholders for both species. Can I go back? Yeah. But we do see for goats that we have more of a behavioral concern here as well. So things like agonistic behavior, food competition was something that was quite high up on our list of priorities in our stakeholders in goats, whereas that didn't really appear for sheep. And you can also see that environmental issues around the quality and the management of environment were things that our stakeholders found important. And many of these things, as you go through the talks that you'll hear for the rest of the conference, you'll see that these are the issues where we have focused in our work. So having prioritized the key welfare issues, we then had three main strands of work around welfare assessment. So the first of those was if we were to measure these welfare issues on farm, what existing PLF tools or technologies might be suitable for allow us to try and understand these small ruminant welfare issues. And this was based on our understanding in the literature. So as Paul already mentioned, there are almost no validated pieces of PLF technology for these animals. So we based our selection of those tools on our biological understanding of the welfare impact on that animal. So what is the likely outcome? What can we see in the literature that we know if the animal has a particular disease, has inadequate nutrition, has a poor environment, we would expect to see changes in the animal's response. Our second strand of work was to test some of these PLF technologies and collecting the data, of course, on the technology, but alongside that, having a set of validated animal-based welfare assessment indicators or methods. And that ensured that when we measured welfare across the different farms and partners, and again, you'll hear more about that later this afternoon. And that was just to ensure that welfare was going to be measured consistently on all the farms. So if we wanted to compare different farms, different countries, different partners' data, using the same PLF tools, that welfare was being assessed in the same way, regardless of the different types of farms in which these animals were being kept. And thirdly, we looked at some novel PLF approaches, so things, new sensors that perhaps had not been used on animals or on small ruminants, perhaps had not been used in the same way. And could we start to identify some new methods that might allow us to monitor other aspects of sheep and goat welfare? And again, this is part of the coming from a very low base, where we have very few existing technologies, and could we, through the work of Tech Care, develop some better understanding of how these novel technologies or existing technologies used in a novel way might help us understand more about animal welfare or the welfare of our sheep and goats. So I'm just going to go through those three strands. So our first task, I suppose, was to think what is the relevant PLF tools for the main welfare issues. So how can these welfare issues be assessed by tools that might already be available to farmers? So across the European Union, animals have to have electronic identification. So could we make use of that relatively cheap and simple technology to understand what might be possible? And we focused on nutrition, disease, and environment. And just like Paul, I've put behavior in brackets because although we know it's important, it was something that was really beyond the scope of the project. And we also considered whether the sensor should be on the animal. So we've heard a lot about dairy cows that actually are carrying quite a lot of technology around with them, which has some advantages, but also some disadvantages. Often they're more expensive. They're more, when we put our animals outside, they're more likely to get damaged. There are a number of issues with the animal carrying the sensor, although they can be really powerful. And we also looked at ways of using sensors that aren't on the animal, but allow us to assess a range of different animals, so things like cameras, for example, which we've heard of from Baz already, and microphones, and those sorts of sensors that collect data on a large number of animals without each animal carrying the sensor themselves. So the main question that we wanted to ask was, what is the impact of the welfare issue on the animal's responses, or in particular changes in how the animal is behaving, interacting with the environment, or its bodily state. And so from the literature, we could see that of the prioritized welfare issues, we could group those together a little bit into the sorts of responses that the animal might make when they have that welfare concern. So things like changes in body state, particularly weight, but could also be body fatness, changes in behavior, so the animal might change its movement patterns, its activity, its food and water intake, its social contacts. It might have altered diurnal rhythms or more blunted circadian rhythms. So there was a number of things that we could predict that the animal might show when it had those welfare problems. And we also knew that there were, again, from the literature, there were potential environmental risk factors for poor welfare. So those aren't directly measuring the animal and the change that might come about, but tells us something about how risky that environment might be for the presence of a welfare problem. And so by understanding how the welfare issue might impact on the animal, we could then predict which of the PLF technologies that were available to us might be most useful in terms of taking things forward to understand whether this could work as a way of predicting when an animal is developing a welfare problem. So these are some of the examples of, and again, Claire mentioned some of these, and you'll hear more about these as we go through the day. So the first of these was, what could we do to measure changes in weight? So that could either be weight gain or loss in an adult, or impacts on growth rate in our young growing animals. And we know from the literature that slower growth is associated with a raft of different welfare issues: disease, a poor maternal relationship, parasitism, for example, in lambs. That weight loss in adults is associated with things like food and water access, heat stress, stocking density, disease, and parasitism. So there was lots of reasons why understanding how weight changed over time would be valuable from a welfare perspective. For our dairy animals, having milk meters and those individual records of changes in milk yield, which again, something that we've heard about from the dairy cattle industry, gives us that understanding of how milk yield can be affected by things like undernutrition, heat stress, environmental challenges, and disease. So we start to build a pattern of things that we might be able to use. Not all dairy farms, dairy small ruminant farms, have access to individualized milk meters. So we also considered at a group level, it may be possible to see impacts at the level of a farm of things like heat stress, environment, nutritional management, by understanding the impact on milk yield at the group level by using measures of the bulk tank weight. We may be able to monitor the individual animal movements and how they accessed key resources from the use of tags, which the animals already have, and placing readers in key locations around the farm. And we know again from the literature that changes in access patterns, daily rhythms can be associated with things like disease, heat stress, poor availability of key resources. So for example, if animals are having to queue to access the same resource. And then from an environmental perspective, we could use weather station or environmental sensing to understand more about temperature, humidity, and various environmental parameters such as air quality, ammonia, and so on, which we know to be risk factors in the development of heat stress or respiratory distress. And we also, and you'll hear about that later this afternoon, also use some of these sensors to understand journey structures when animals are being transported. And finally, we also used, sorry, this one probably should belonged up with tags and readers. We use that movement of animals, particularly our dairy animals that have a very predictable movement through the milking parlour every day, and whether we could understand that movement pattern and the animal's individual position and status within the herd, and whether that was indicative of disease in those animals. So we had a range of technologies that were already there. They could already be implemented on the farm. They hadn't been validated for some of the uses that we wanted to use them for in terms of animal welfare, but we knew that we could put those on farms and collect data that was relevant to our welfare issues. So to allow us to also collect data in terms of this new purpose for the PLF technologies, we needed a set of welfare indicators that were robust, hopefully validated, and would allow us to assess welfare in the same way across our different farms. And for this, we drew heavily on the previous EU project, the AWIN project, which developed animal-based indicators for sheep and goats. We also made use of the AssureWell project and our individual partners' own research tools to assess welfare. So we had a range of different things at our disposal to develop our list of animal welfare indicators. Our approach in doing this was because we wanted to relate it to our individualized PLF data from our sheep and goats, was to assess each individual animal. So we weren't using, so the AWIN project and other projects have tried to give a sort of global view of what's happening on a farm. And that wasn't our target for this work. We wanted to understand what might be happening at an individual animal level, and then we were making those measurements at a much higher frequency than you might do if you wanted to just assess a farm. We developed a core set of animal-based indicators or measures that focused on the top 3 prioritized welfare issues for each country by species or purpose. So again, rather than it being a global view of everything that the animal might experience, we tried to focus on those issues that were most important to our stakeholders and where the focus was in using some of our PLF technology. We also recommended other indicators that covered all the potential welfare issues that the stakeholders had identified for the species. And then we added some additional measures that would give us sort of overall welfare information. And that was sort of optional for the different purposes, but if they were going to be measured, we wanted to make sure that they were done in a standardized way. The majority of the indicators that we used came from previous projects or had been validated in the literature, except where none existed, and therefore there was a little bit of the sort of face validity in some of these measures where there was nothing in the literature that we could use. Additionally, we collected resource-based measures. So, for example, things like the temperature humidity index in a barn, or at the group level, so that would be things like bank milk tuck, somatic cell count, for example. And we also created resource and management check sheets so that we would know, because of the diversity of our different farming systems, we would know more about the way in which those animals were being farmed. So I thought I would just give you an example. So here is an example from dairy sheep. So the core issues that were identified were mastitis, lameness, gastrointestinal parasites, nutritional issues, issues around the housing and environment, including the quality of the bedding, diarrhea, and abortion. Within that core group, or in addition to that core group, there were other issues that for some countries, some partners had raised as particular concerns for them, even though they weren't the concern for all dairy sheep producers across Europe. And that included things like respiratory infection, competition and aggression at the feed face, the quality of water that the animals had access to, heat stress, handling, and ectoparasites. And so we also created indicator lists for those conditions as well. We included qualitative behavioral assessment as a way of getting a more global view of how the animal was coping in the environment, and to try at least to tap into the sort of mental state component of what the animal might be experiencing. And then we produced a list of indicators and information on how they should be scored or measured. So as an example, some of the issues that came up for dairy sheep, we had 2 lists of indicators. So for some animals that were inside all the time, they may be handled every day. But for animals that are living outside in a very extensive environment, they may only be handled typically 3 to 5 times a year. And so we needed a range of different indicators that would work inside those different conditions. Even though, obviously, from when we were doing some of our early piloting work, we were increasing the frequency with which we were collecting these data, we couldn't impose a system where we were measuring these data every day, because we're probably going to be impacting on the welfare of those animals to do that, and that was just beyond the scope of the project. So for most of our measures, we had something that could be measured in an unhandled situation in the field, if that was possible. And then we had, and you can see on the right-hand side, there's a longer list of things. It is a lot easier to measure welfare when you can get close to an animal and handle them and really look at the animal in detail. So you can see that we have a list. I won't go through them all, but and these are, are pretty common measures that we would find on most welfare assessment projects. And a lot of these, as I say, were drawn from the AWIN project. And then for each of our lists, we then also had a document or guidance on what that looked like and how it should be measured. Again, a lot of this we took from the AWIN project, but we did adapt some of the measures in some places depending on the experience of using the AWIN project and protocols in some countries, and also just to focus a bit more in some places on what was important to our stakeholders. And this is an example of the sort of information that we also explored when we wanted to understand what resources were available to an animal as well, to give us a sort of greater depth of understanding of what the data might mean. So we heard earlier about the importance of having the metadata that sits with the indicator data, and you can see that we had a few rounds of sort of expert panel meetings to come up with a list of things that we felt were important parts of understanding the data when we looked at welfare indicators. So the final part of developing this list of indicators was working with one of our SME partners, Breeder, who already had an app that was used for sheep farm management for things like production and growth. And then we added with them, I didn't do it, they added the welfare indicators onto the app so that it was then possible to collect those data through the app rather than pen and piece of paper, although that's also fine, but just to speed up the, and to sort of ease the collection of data, and then we have all the data together in the same place. So these animal-based indicators have been used in a variety of different scenarios with our different species, animals kept indoors, kept outdoors, with lambs at foot, without lambs at foot, in a milking environment, in an outdoor environment, which is very challenging. And you'll see some of the information about this as we go through the rest of the presentations. So the final part that I'm going to talk about, I'm conscious of time and I stand between you and your lunch, so I will endeavour to do this quickly. You will hear more about most of the things that I'm going to talk about perhaps in more detail as we go through the day. But one of the sort of questions, because we were coming from a position of ignorance, I suppose. I mean, there's a low level of sensor tech that is validated for the things that we wanted. And often a lot of the questions we were asking was, is there even a behavioral indicator that would serve as an early warning system for this welfare issue? So we had sort of twin levels of known unknowns. So we didn't necessarily know what the animal would do, and we could predict what we thought they would do, but we didn't know for sure that that is what they would do. And we also needed then to know, could we measure that change from some method of using PLF? So I'm going to give you a few examples. You'll hear more through the day, and you may hear more about some of these examples. But I'll talk a bit about work done by 2 of our PhD students, looking at assessing social interactions between ewes and lambs, using a way of assessing proximity between different members in an outdoor environment where they weren't entirely free moving, but they had a lot of space to allow us to see these sorts of natural changes in social interaction. We focus a bit on how animals use the space, again, particularly outside, but also inside, and how that rhythms of behavior might change over time if the animal has a particular welfare issue. And some of that was the change in spontaneous behavior, so how they access different resources, how we could potentially predict their different movement patterns. And here in particular, although we might be able to do some of these with things like accelerometers, they're really expensive, they're quite challenging in the environments in which we might want to put them. So are there other ways of allowing us to assess this sort of information? And we also asked whether we could use PLF technologies to understand the environmental risks for welfare. So could we get better information on the potential risks that animals might be experiencing in different environments? So the first of these is to look at changes in social behavior, and this was a study done again by our 2 PhD students in SRUC, using Bluetooth beacons, which the lambs wore around their necks, and ewes who wore a receiver and a beacon. So the lambs would transmit just out, and the ewes would both receive and transmit. So we could understand the relationships that the ewes might be having both with their own lambs and with other ewes, and for the lambs, it was their relationship with other ewes. And what we showed was that when animals were lame, so when the ewes were lame, they had more contacts with their own lambs and less contact with other ewes. And they were closer, I don't think the pointer really works, does it? They were closer to their own lamb when they're either lame, or it's a score of the fleece quality. So that tells us something about ectoparasites. We often see the ewes will lose fleece when they are parasitized, but it's also a response to chronic stress. We see breaks in the staple of the strength of the staple from the wool, and so the ewes will also lose fleece when they're stressed. So we can't say from this data which of those there was, but we could tell that when the ewes had lost fleece or were lame, that their lambs were closer to them and they had less social interactions with other ewes. So painful welfare conditions, such as lameness, altered the social relationships that ewes had, such that the lame ewes had more contacts with their own lamb, but less contacts with other ewes. And those ewes that were either lame or had excessive fleece loss were closer to their lambs than ewes without those conditions. So although it wasn't specific for what was happening, we could see this change in social behavior related to the ewes' experience. Another example of some of the data, and this was done in Norway, looking at real-time tracking of movement and location of sheep and goats in a very open environment, so unfenced environment. The animals can move in many different locations, and that allows the tracking of where they are and how much they are moving in real time, and that can be fed back to the farmers. So the farmers can see their animals moving about in the environment, see how far they went or how far they didn't go. And it also allows things like detection of activity spikes, and changes in behavior, which were shown to be related to predation events and to mastitis. So we're starting to see changes in the animal's location and behavior measured in real time associated with different welfare events for those animals. Another area of work, again, done at SRUC, but this time focusing on how animals are using the different sorts of resources. So you can see an example at the top of animals coming to a feed block, and then we have a reader above, so the animals come at different times in different ways to access the feeders. And again, these are in large open environments, so sometimes the animals may come many times a day, sometimes the animal may only come once or twice a day. And what you can see in the sort of wavy blue line is the number of the time that the ewe came and accessed the feeder. This is an example from one animal across time. And the two sort of peaky bits you can see are at dawn and dusk. This is in Scotland in February. We don't have very long days at that time of year, so they're a bit compressed. But this potentially gives us an opportunity to identify changes in diurnal rhythms and how the animals are using the landscape without them having to carry those GPS or GNSS devices. We can use it by their ear tags or a smaller device by having readers at fixed points. We can show from this that resource use is, their visits to these different resources is influenced by the weather and also by the breed, but potentially also by different welfare challenges that the animals might be experiencing. In an indoor environment, and this is work done by Idel, and follows on from work done by the Volcani Centre, ARO. When animals are housed, we can gather so much more data than we can get in our farmed environment. And this is looking at water use by lambs. So you can see in the photograph the plate reader above and the lamb coming to drink at the water feeder. And we can get this much more detailed data that shows the patterns of movements of these animals as they come to the drinker. So the red circle shows you an animal that suddenly changes its behavior over a number of days, associated with the development of an acute painful condition. And the green dots show a slow decline in the animal's use of the drinker over time, associated with more chronic condition. So the data, these are just examples of sort of case studies, but the data starts to build together a sort of understanding that we can assess how the animals are using different resources and how that might change over time with different sorts of welfare conditions. I think this is my final example, which again is looking at how animals use a milking parlour. This is data from UAB. And we know that ewes, and these data confirm that when the animals come through and there's a reader that checks the identification of each animal as they go through, that they enter the milking parlour in a consistent order. And these data show that that was particularly so at the start and the end of a movement order. The animals are very consistent in how they came through. In one of the breeds of sheep, this was correlated with somatic cell count. And there was a understanding, or that there was evidence that sheep that were at the back of the order were those that had the poorest udder health. So the position in the milking order, or the point where the ewe presented herself to come into the milking parlour, was affected by her somatic cell count and her udder health. And another set of data also looking at the same issue, so this is from Sardinia, and again was analysed by our partners in Israel, showed the changes in milking parlour order when animals have low somatic cell counts, so there's the pale blue bars, and animals that have high somatic cell counts, that's the dark blue bars. And 3/4 of the ewes that had high somatic cell count entered the milking parlour later than we would have predicted from their previous behaviour, so they moved back in the order. And those animals that had low somatic cell count tended to maintain their position. So there was a shift backwards for those animals that had a high somatic cell count. You will hear a bit more about some of the ways that we might assess environmental risks. So this is, again, thinking about the risk factors to animals rather than directly measuring the behavior of the animals. These are some data looking at the sensory load that animals experience when they're transported in different ways. So this was work done by SRUC and UAB. This work was looking at how animals were transported by sea. And what it provided was further information about the overall experience that animals had when they were being transported in this way. We collected data on their behavior and could show that that was affected by those sea conditions. So the risk factors were correlated with how the animals responded. And we were able to determine that these environments were very noisy, very unpredictable, and the animals were subjected to forces in different ways, and that was mirrored in their behavior. And the final example here is when the animals are transported by trucks in various ways. And what we can see in the top panel is what the lambs experienced is a different and more challenging environment, greater vibration, greater forces on the animals than what the driver is experiencing. So the driver's perception of the sensory load on the animals is very different. And similar results were shown by UAB when transporting both goat kids and lambs, that the top two panels show the animal's experience of acceleration and forces on the animals, and the bottom two panels show the driver's experience. So much greater forces applied to the animals than to the driver. Similar to the data that we collected when animals were transported by sea, we can also see that there is a much noisier environment for the lambs and the kids when transported by road, as well as at sea, compared to what the drivers are experiencing. So we're starting to capture some understanding of the sensory impact on the animals of these different conditions. So in general, whether the animals are transported by sea or by road, the transport environments are very noisy. So there's a lot of sensory load on these animals, and they also experience vibration and acceleration, which is much greater for the animals than it is for the driver. So the driver doesn't necessarily perceive the experience of the animal in the same way. So just to conclude what we have achieved in the Tech Care project, we developed a prioritization of welfare issues for sheep and goats across Europe, and that was based on our stakeholders' perceptions of what was important, and that ensures that the results are rooted in the experiences and concerns of those who might then go on to use any PLF. I'm nearly finished, Claire, if you're coming to stop me. We determined the main areas of animal biological responses that we should be looking to assess as part of the early warning system, and that was important because that allowed us to test possible PLF tools on farm. We defined standardized measures for welfare assessment that allowed common approaches to be taken across the project partners, and that was incorporated into an app to make that easier. And we've created some new knowledge on methods of assessment or potential methods of assessment of welfare using PLF that might improve welfare monitoring and management in the future. So that is by looking at or trying to look at some social interaction data or social behavior, the movements and locations of animals, and how they access different resources. And so in terms of measuring risk factors, we also provided some new approaches for assessing the impact on animals of transport under different conditions. Thank you.
No, I know it's food soon, but is there anything online?
No, not yet.
No. Okay.
They've heard it all before.
Yeah. No,
Apart from Paul.
Thanks, Cathy. I think, well, most of the results you presented here, I think are a great step forward. So I think the situation now is quite different than when you started 5 years ago. So I wonder whether so in a global perspective, do you see PLF being established in small ruminant production in a commercial situations? So how far or close do you see the implementation of these technologies on a regular basis on sheep and goat production?
I might be slightly stealing the thunder of the people who are going to speak a bit later, but I think just as so I think some of the things that we started with, the things like the weigh crates, the assessments of milk yields, the things that we already had known PLF, some of those were already on farm, some of those were transferred to the farms. I think, and we've done, and again you'll hear more of this later, that some of the stakeholders that have, as part of the sort of discussions with stakeholders, I mean, certainly from our UK perspective, there were farmers who were really interested in taking it on board. Things like the automated weigh crates or adding some more automation. So I think the more established things, I think not every farmer will take them up, but I think there will be farmers who will start to use some of those things. Maybe not for welfare directly, but because they can see a production advantage as well. But if that also helps in terms of understanding welfare and improving animal treatment, for example, then I think that would be beneficial. I think the things that I talked about at the end here are quite far from market. No, actually not the environmental sensors, I think, and you'll hear more about that as well, that's much closer to, so the assessing risk factors. I think the things that might give us a better understanding of animal social behavior, animal landscape use, I think, I mean, we've started on that process. In places like Norway, some of that data is commercially used, so the collars are used for location by commercial farmers. And what we're thinking about is novel ways or better ways of understanding the animal's experience from those uses. I think it'd be hard to have a sense that just measures welfare and nothing else. I think that's the problem. Farmers will find that difficult and challenging to take that on board without some, I think as you said, some creative value chain model that rewards that response. But I think where it's linked to production, then I think there is interest from some farmers to take some of these things forward.
Yeah, thanks, Cathy, for a nice overview. I was quite intrigued with your idea to work with the Bluetooth beacons for the ULAM and the UU contact. Is that something that can also be developed more for practical application, or is it really a research system?
I'm going to defer to our glamorous coordinator here because she knows a lot more about this. But I think from what she was nodding, I think it has commercial application for sure.
I'll say more about it tomorrow. But it's something that is quite promising because it's a small beacon. So the farmers are quite happy with that sort of level. And the technology is already there for something else. So that was one of the promising innovation, that one definitely. And it works outdoor. You don't need tons of battery, which is good.
And yeah, and that would be a huge issue for any of the people outdoors, is lots of technology does not like to be outside in the rain and the snow. Funny enough. And big things, sheep don't like to carry big things around their necks either, or heavy things. So something small and light is really valuable.
And that's something the farmer said, is if you could have a mini tag that records everything, then we'll buy it tomorrow. So that was the kind of a guideline we had from them. So. Any other question, or we just have lunch? Well, thanks everyone for this morning. I think it was a nice presentation, and this afternoon we'll have much more details on what Cathy presented, what I started to present. So hopefully you stay awake for this afternoon. But in the meantime, the food is just through the door, and we reconvene in 1 hour, so at 1 o'clock. Okay? Thank you.